So now we're going to be talking about rational exponents, which just means exponents that are fractions. So here's just a reminder of our exponent rules. So go ahead and make sure you look over the properties and you are familiar with these. And then here are some examples when they are shown with fraction exponents. Whenever you see a number raised to a fractional exponent, here is how we convert it to a radical form. So we have m over n, where m and n are both real numbers, and n, our denominator, becomes our index, and m is the exponent on the term. Now, notice how you can write it two different ways. We can have our exponent underneath the radical, or we can have the entire radical raised to that exponent. Now, before we convert this into radical form, you want to make sure that your exponent is always in lowest terms. So for these examples, we are going to rewrite in radical form and then simplify. Well, whenever I have anything to the 1/2 power, the 2 is going to be my index, so I'm going to go ahead and write that in the index, and then the number underneath, and now I'm just raised to the power of 1. Now this should be familiar to you. This is just the square root of 36, which we know is just going to be 6. So in simplified form, we get 6. Now over here, since we have to the 2/4 power, we're going to go ahead and simplify that. So I'm going to rewrite this to the 1/2 power. And then we are going to apply our exponent to all of our terms. So we're going to have 6 to the 1/2, y to the 1/2, over 25 to the 1/2, x to the 1/2. Now we're going to start rewriting our terms in radical form so that we can simplify. So 6 to the 1/2, that's just the square root of 6. Y to the 1/2 is the square root of 6. So I'm going to go ahead and write those underneath the same radical, square root of 6y. And on the bottom, we're going to have the square root of 25 and the square root of x squared. Now hopefully we can simplify these okay. On the top, I'm going to be left with the square root of 6y, and on the bottom we're just going to have 5x. So that will be my final answer in simplest form. So now we're going to do some more examples of rewriting it in radical form and then simplifying. For example part C, it's important to recognize that the 2/3 is only on the x, not on the 8. So when I rewrite this here, the 8 is left alone, and now I'm going to have the cube root of x squared. Now there is no cube root of x squared, so that's going to be my final answer written in radical form. Now in part D, I have negative 27 to the 2/3 power, so rewriting that, I can write it in two different ways. I can write the cube root of negative 27 to the 2nd power, or I can write the cube root of negative 27 and then the entire radical raised to the 2nd power. Now this second way of writing it is going to be more helpful for me in this example. Because I have a cube root of negative 27, it's negative 3, and then I just square the negative 3, so positive 9 is my final answer. If you do it the other way, you're going to have to square negative 27 and then try to find the cube root of that bigger number. So if it benefits you, I would write it in this way in order to simplify quicker. Now for this problem, we normally cannot do anything when dividing radicals with different indexes. But using the properties of exponents, we can rewrite this in exponent form and then use our properties to divide. So this is going to turn into x to the 3/4 power. Remember, the index is the denominator. And x to the 2/8 power. Now, using my properties of exponents, I can subtract these two. So doing a little side work down here, subtracting these fractions, I need common denominators. So I'm going to go ahead and multiply this guy by 2. So this is going to be 6 minus 2 over 8, which is 4 over 8, which just simplifies to 1/2. So this is going to be rewritten as x to the 1/2 power, which we all know is just the square root of x. So that's going to be my answer in simplest form. So in this example, we have a decimal exponent. So we need to rewrite the decimal into a fraction. So negative 2.5 is equivalent to negative 5/2. So rewriting this as 16 to the negative 5/2 power. Now remember, you cannot have a negative exponent, so that guy flips to the bottom. Now we are just going to evaluate what this is in radical form. So that's going to be the square root of 16 to the 5th power. I wrote it this way because it's going to make my life easier. So now that's 1 over 4 to the 5th, which can simplify to 1 over 1024, and that's going to be my answer in simplest form. So for this example, we're going to have multiple steps. The first step is to rewrite the radical that is in the parentheses so that it has a fraction exponent. So that's going to be the 1/2 power whenever we have square root. So now we're going to distribute that 2/3 power to every term. Now remember, when we do xy to the 1/2, you multiply times the 2/3. So simplifying that, well, now we can see that we're going to have a -8 to the 2/3, which is the same as the cube root of -8 squared. Then I'm going to have the cube root of x squared, and then these guys will simplify to just simply 1/3 power. Now the cube root of -8 is -2, so that's going to be -2 squared. And then I'm just going to simplify back here. This is going to be the cube root of x squared. Well, now -2 squared is just +4. I can rewrite these last two under the same radical since they have the same index. So it's x squared times x times y. Now we know that x squared times x is x cubed. So I'm going to rewrite that as x cubed times y. And the cube root of x cubed is x, so this will simplify to 4x cube root of y. So lots of steps, but showing all your work, make sure that you don't miss a property somewhere and you don't confuse yourself, so make sure you show all your work. Alright, so now it's your turn to try. So remember all of your exponent properties, remember how to switch from exponential to radical form, and for these last few you might want to switch to exponential form to be able to simplify.